Hello and welcome to this month's Aerospace Testing International podcast. I'm Ben Sampson. For this month's podcast, I talked to Brandon Robinson, CEO of Horizon Aircraft. Horizon is developing the Cavorite X5 eVTOL. The X5 will have a top speed of 280 miles per hour, a range of more than 300 miles, and be able to carry 5 passengers. Horizon is a small company making big, ambitious noises, and interesting to me is the long range of the aircraft, the fact that the company is opting for a hybrid electric powertrain and not talking up ranges with batteries or using a future propulsion tech like hydrogen. Brandon's also a former fighter pilot and has some great experience and contacts in the aviation world. He talked to me from Toronto, Canada last month. Great. So, tell me about the business first of all. How many people have you got? What kind of are your areas of expertise? What's your own background?
Yeah, so our team's up to about 20 now, but really honestly, right now, the challenge is onboarding folks fast enough. Aggressively growing the team is kind of both awesome and difficult. For example, our last job posting had more than 200 applicants. So we're finding, here in Toronto, Canada, the talent pool is actually quite exciting, and we're pretty stoked about the Canadian aerospace sector. And we're finding a pretty cool blend of basically experienced leaders and then some smart young talent that wants to come on board. So mainly research and development focused team, but with the ability to sort of fabricate and test our own designs. I call us kind of an agile yet hungry group. That's going to be sharply focused.
Okay. Tell me a little bit about the aircraft, the Cavorite X5. How have you arrived to be producing this aircraft? It's got quite a good backstory, an interesting story, haven't you? The company.
Yeah, we have actually. So it actually is quite interesting. It's been kind of an organic development process. So back in 2013, we were actually formed the company around developing a brand new prototype for an amphibious aircraft. So my father had recently retired from Johnson & Johnson Pharmaceuticals. He'd been a lifetime professional engineer and been an aerospace tinkerer and, over 50 kind of modifications in our own aircraft and done a ton of different modifications. And a gentleman approached him and wanted a new design that was based on our own 1946 Republic CB amphibious aircraft design. So beautiful old flying boat built back in the late 1940s by Republic, and this kind of cult following in general aviation. And my father had started doing a bunch of modifications that were popular in that space. And a gentleman wanted a modern version of that aircraft. So we began looking at how that was going to come together. And the development progressed very well. And that was actually our first prototype design. So we call it the X3. We have some patents for that, pretty innovative design. We built a quarter scale model, flew very well, and had some great hydrodynamic properties as well. Mm-hmm. But then we started looking always at improving it. So a way to improve the stall performance is what we were trying to do. And to be honest, that's where we started looking towards, initially putting a couple fans in the wings and, augmenting the thrust that way instead of building a fatter wing and a slower aircraft.
Right.
And it just kind of organically grew from there. So we end up with our patented fan in wing technology. And we realized, hey, this thing can take off vertically as well. So that was pretty cool. So honestly, instead of starting out and trying to build a VTOL and then finding a market for it, again, more of an organic process, looking to, mission first, build some specs, and then, developed into a pretty cool eVTOL design eventually.
So you've got a very clear idea of the market that you're going for with this aircraft, right?
Yeah, exactly. So, we started from a regional kind of perspective. If anyone is, from an amphibious perspective, if you want to do useful work and take people useful distances, it's got to be in that 300 to 500 kilometer range, with the reserves for VFR flight and whatnot. Mm-hmm. So we realized that when we started doing market research, there was a gap there. So wanting to bridge that gap and see now, where that future would take us with the eVTOL capability layer over top of that. And we'll talk more about the hybrid architecture and why that's in place. Mm-hmm. We actually found a really cool underserved market niche, and it, like I said, it was a more mission focused than it was a if you build it, we'll find some area for it kind of approach. So we're pretty happy about that.
Okay. And what about yourself? You neglected to tell us what your background is.
Sorry. Get all excited about the prototype. That's classic, right? So personally, I went through the Canadian Air Force and flew CF-18 fighter aircraft. So I was fortunate enough, with the help of some really cool friends, actually to pass the Canadian Top Gun course. Also picked up a mech eng degree along the way and got a license to be dangerous in business with an MBA. So honestly, like a license to be dangerous, like I said, in a number of different areas. So jack of all trades and absolutely master of none. The guys remind me that on a daily basis. Okay. So I can really mess things up. But so I stay back in the strategic level and really just try to keep everyone organized right now. Okay. Also did a stint in international HQ, which is pretty cool from a project management perspective, buying weapon systems for the F-18 and integrating them, fixing the sim program and whatnot. And along the way, I mean, I think the highlight is tons of cool industry contacts that have been proven really valuable along the way. So world-class test pilots, guys, ex-buddies that are now into the regulatory structure and industry leaders that, the network has been pretty fantastic. And that's really helped us accelerate the program.
Okay, great. So, I mean, how can I put this? I mean, eVTOLs are kind of quite on trend at the moment, if there is such a thing in the aerospace sector. Quite fashionable, I guess, in a way. I see a lot of them. I mean, your design, you're coming at it from a different kind of way. You've explained how it was organic, but I mean, can you tell me any more about the aircraft itself? And you're choosing to go this hybrid electric route instead of pure electric. Can you explain some of the thinking behind that, please?
Yeah, well, and great question. And the first thing is I get some heat every once in a while from saying, everyone thinks I think batteries are terrible, and pure electric vertical takeoff landing machines won't work. But that is completely not the case. But I mean, when you start from operational parameters and distill some specifications, and from us, we started with ranges of 300 to 500 kilometers, and distill that into what that engineering would look like for the VTOL. And honestly, for ranges over 100 kilometers in any operational environment that requires aircraft to adhere to the mandatory minimum fuel reserve. So like I said earlier, for instance, VFR flying, you have to get to destination, then be able to fly for 30 minutes thereafter. I mean, it really did require a hybrid power system. I mean, it wasn't even close. So it really was simply not practical to consider purely electric power for our ranges and for our speeds that we wanted, due to just simple battery power specifications. So even packed batteries of 200 watt hour per kilogram, still not hacking it. And those higher energy densities also come with a concordantly more fragile chemistry that you can't charge or discharge very quickly. So power density was kind of what we designed around. Interesting, and we talked about this before we started. The hydrogen angle has actually been quite interested for us, but again, from an operational fighter pilot background, I start to consider how the machine's going to be used and how robust it's going to have to be. And for us, although it's very interesting and accelerating rapidly with proton exchange membrane, all that sort of cool technology advances, the infrastructure was just not in place to support the operational elements for us. So
it's still quite new technology, right?
It is, yeah. And I mean, and so you're looking at power densities. I don't know what the latest is, like maybe call it 2 kilowatts per kilogram. So if it's a high power requirement for takeoff for any eVTOL or any VTOL. So if you're looking at 1,000 to 1,500 kilowatts, you're 500 to 750 kilograms of batteries right there, and that's So or not batteries, sorry, of hydrogen. So. It's challenging from just an aerospace engineering perspective.
So how long have you guys been working on the X5 then? Since?
Oh, we've been working on the last 3 years. So it's since 2018, roughly speaking, and development was slow initially and accelerating.
Yeah. When are you talking about delivering your first aircraft by or certification by?
We'd love to have certification completed by 2025, to be quite frank. It's an aggressive timeline, I get it. But we have a solid approach, just like most folks.
Yeah. And where are you at? Where are you with regarding development at the moment? Are you working on a prototype at the moment, or?
Yes, actually. So we have two flying subscale prototypes at this point, and we're working in the next 12 months. We'll have a much larger, kind of 60% scale prototype. So taking a stepwise approach to it, not trying to jump too many steps. So it is again sort of an organic development process. But I think a lot of people think it's a very linear thing. You do this, then you do this, then you do this. But really, So we have full-scale prototype, that's been in design, and so we're going to be building full-scale prototype components. So, for example, the full-scale wing to test that. Mm-hmm. We have a full-scale cockpit mock-up already built to test some of the human factor stuff. There's also that 60% prototype that's a little further along in the design phase because we got to be done that in about 12 months. Mm-hmm. And our subscale prototypes are through, like I said, 200-ish or more now test flights. Mm-hmm. For what that's worth. So a lot of parallel stuff going on.
Yeah. So there's lots of, I get that, lots of different parts. I mean, obviously bringing it all together and integrating it as a whole, you'll know that that's the most difficult part a lot of the times. I mean, are there any aspects of the sort of development and testing that I don't want to say keeping you awake at night, but kind of you worry more over? So, I mean, the fan and wing technology maybe that you've mentioned, or the control systems, or the transition from vertical to horizontal. What are you most worried about?
Well, it's a great question, Ben, to be honest. I mean, so it is so fan and wing technology, control systems, vertical to horizontal transition. So from a certification perspective, it's tough to separate all the elements because, I mean, take the EASA VTOL means of compliance or special SC on it. And the FAA is the same way. You have flight, and then you have kind of structures and design and construction of everything. And then for EASA, they divide it out into lift and thrust systems, I think. And then there's a few other things, system and equipment and human factors. So multiple sort of pillars in certification and how you're going to, certify each individual component. And so there are, for us, all those three, our fan and wing technology, the control systems, and the vertical to horizontal transition are all sort of mixed together. So I think we could go into each one of those pillars and kind of our thoughts on how we're going to, for example, certify the power system for the vertical lift fans. How the main hybrid system looks for providing that horizontal thrust. But really, I mean, writ large, optimizing the thrust from the in-wing fans while keeping the whole system light enough, simple and robust, and easy to manufacture and maintain. Would be near the top of the list. The opening and closing mechanisms, we want to make them robust, fail-safe. If you have an asymmetric opening of one of those, it wouldn't be good. And so I guess that would be sort of the forefront. So making sure we have enough thrust, keeping the whole system light enough would be the thing that I guess if you say keeps me up at night. There's a lot of other stuff too, but that will be one of our main challenges. From a certification perspective, well, I think we have an advantage in that, for 98% of the mission, the aircraft flies in a configuration exactly like a normal aircraft. When you talk to regulatory folks, they can integrate, the risks are integrated over the entire mission profile. So when you have an airplane that acts and flies like something they're very familiar with, that integration process of taking the risk and looking at it through the entire mission profile becomes a more understandable equation for them. Mm-hmm. So they say, okay, well, the aircraft flies like a normal aircraft if it works, which it will, for 98% of the mission. We know that. And now, okay, you have a VTOL component to it. So that can be seen as an additional layer of safety. For example, if you slow down too much en route, instead of stalling and maybe going into a spin, the aircraft will warn you, and then the wings open, and it will prevent bad things from happening. So, call it a controlled descent or whatever. And it tells you, it's flashing warning, hey, speed up, idiot, you're going too slow. So from that narrative, it's, there's challenges ahead for certification, but that's been a positive dialogue with some of the regulatory folks. Yeah,
you're kind of chunking it down and approaching the problem as it comes. Great. Yep. I get that. I mean, you mentioned regulators there, FAA, yeah. So are you working with FAA at the moment, or Transport Canada, or at the moment? Are you talking to those guys, or is that to be done?
Yeah, we're in unofficial talks. So, like I said, we're trying to wait for things to settle down a little bit and for folks to figure out exactly what eVTOL certification is like.
Yeah.
It's interesting. A lot of other companies will have entire lobbying arms that, they're trying to shape the regulatory structure. All that takes money and personnel. We want to maintain focus on just building a really cool machine. So once things settle down a bit, we'll engage a couple of groups formally. And that's going to happen, honestly, a little bit sooner rather than later with our recent acceleration. But yeah, so on an informal basis, we're talking to regulatory groups, and we'll engage shortly.
Well, I guess a lot of companies and a lot of journalists would see eVTOLs as a race to market now. Do you see it in those terms, or are you kind of outside of the race? I guess you got to be careful what you say here.
Well, it's a race, but it's not a sprint. It really is more of an endurance run, so a marathon.
Yeah.
And so you have to pick a realistic endpoint, and then develop a smart machine that honestly is going to work. And when the dust settles and the consolidation in the industry is going to happen, which it will, I think the great designs that, again, can perform in a robust operational and difficult operational environment that have a lot of contingency built in, that can overshoot from a fouled landing spot and go to an alternate, can deviate around a thunderstorm, or can deviate, deal with, a 30 knot headwind that was surprising, or a snow shower, or a little bit of rain. Those sorts of designs will come out ahead. And I think the key for companies to, win that marathon race is to stay focused. And I guess, we can talk about what that looks like from a design team size and from a philosophical perspective later. But I think that's the key.
Okay. How do you think the market is gonna progress? I mean, you can talk about it in terms of how is it going to shake out. I mean, a lot of people think that some firms are going to fall by the wayside. Not all aircraft will ever come to fruition. I mean, what would you expect? How would you predict with your crystal ball, I guess, how things are going to shake out? And how do you see Horizon moving forward as part of that?
Yeah, so I think there's going to be a market consolidation where good designs will prevail. In Horizon Aircraft, honestly, we're just going to stay focused. Super agile team. Try not to build out a 400-man team that designs an aircraft by committee.
Mm-hmm.
Stay sharp, build, test, iterate, and keep moving forward. And our engineering will speak for itself.
Okay, sure. Just a final couple of questions, please, Brandon. I mean, in my mind, there's two main aspects to this aircraft. I mean, there's the kind of hybrid electric aspect for the propulsion, and then the vertical takeoff and the transition, of course. I mean, do you see it as a hybrid electric aircraft, or do you see it as a virtual takeoff and landing aircraft first? I mean, which or is it kind of both?
Yeah, so honestly, that's a kind of a difficult question to answer. I see it as both. Mm-hmm. So, like, fundamentally, it's an aircraft that also can take off vertically, so vertical takeoff and landing aircraft. Think of it as a helicopter that can just go twice as fast. It's not good for any long duration hover type stuff. So whether it's an eVTOL or an aircraft, honestly, it's really both and kind of none, because it's a new thing. So It can take off just exactly like a helicopter from just a 30,000 foot perspective, and it can go twice as fast en route because it doesn't have all the blades spinning and creating a huge amount of drag. Normal wingborne lift is kind of its strength en route. So I guess if that answers the question.
Yeah, you sound to me as if you wouldn't really mind what it's called, as long as you can make it and sell it at the end of the day, right? Am I right in saying that?
Sorry, say that again.
You sound to me as if you don't really mind whether or not it's an eVTOL or a helicopter, what it's called, as long as you can make a cool aircraft and sell it at the end of the day. Is that the aim?
Well, yeah, that's a great way to put it. So again, an operational focus, is it able to do missions and replace mission sets that in a more efficient manner that are currently available? So can it fill market gaps currently or in the near future? And if it can, and it will, then it's going to be successful, and we'll sell a bunch of them.
Okay. There's one other thing that I'm really curious about, really. And you're CEO of the company, and you work with your dad. I'm just wondering what it's like working with your dad. because I know from my perspective it might be. I hope he doesn't listen to this, but I might find it quite difficult. Do you? Is it a good working relationship? Is it difficult?
Honestly, it's been great. Yeah, I mean, I've learned a huge amount from already. So he's got 50 years of engineering management behind him, managed complex production lines and in pharmaceutical manufacturing and complex aerospace engineering projects. So he's really brilliant at managing those complex projects, but honestly, as well as coming up with innovative patentable design elements. So that fan and wing technology that is patented now, or notice of allowance has been given, was quite a sort of his brainchild that I helped out with. And so, and there's probably locked and loaded another 10 ideas of his that have some really good merit from an innovative, patentable perspective. But although he has some really amazing ideas and concepts, he also does and is very open to embracing ideas from the rest of his team. And so, opting for, the best solution. So not getting tied to his own ideas. So a true mentor for especially the young engineers, and an excellent manager of those older, more experienced folks. So I don't know if you know the story of Kelly Johnson and Skunkworks, but sort of the same deal where, Kelly Johnson, I think with, what was it like? He built a P-80 shooting star in like 150 days or something with a team of 30 or 40 people. And the team that built the SR-71, and the key to that success. So modern context, by committee, 400 people. Kelly Johnson built the, fighter aircraft in SR-71 with 1/10 of those people. And it's focus, making smart decisions, and moving forward, iterating, testing, and fixing and improving, and not getting stuck with like I said, design by committee sort of stuff. So he's very good at that. And I lean more towards the let's perfect the design first. And he understands the practical utility of building something, testing it, seeing where it breaks, making it better, building it again, and really taking a more practical, speedy approach. And that's fantastic to see, and I've learned quite a bit. So overall, it's been just fantastic.
I'm just curious. One quick question. I'm just curious about you mentioned compare it to Skunkworks and the SR-71. I'm just with the modern tools that you have, the CAD and the simulation tools and the modeling. I mean, how much do you think you lean on those now, or use those? And compared to kind of physical testing and flight testing and ground testing, is it? I mean, maybe you're not so much at that stage yet, but I mean, how does that work out for you guys? Is it?
No, so we've done a huge amount of that, to be honest. So we've spent hundreds and thousands of hours of going through flow simulations and iterating, but the computers are great these days, and some of the simulations are very accurate. So, for example, on our subscale prototype, the flow simulations came out within 5% of the thrust that was actually being produced. Now, that was after quite a bit of iteration, but that was without recalibration. So a lot of the times you'll design in the computer, you'll actually test it, then you'll go back and recalibrate the computer to align, honestly, to get the real world testing to align with the computer. So it's a weird iterative process. And then you can adjust, you can test relative improvements. So, okay, now we've got the computer and the real world testing kind of aligned. We'll go back and we'll tweak something in the computer. And is that a plus or a minus in the computer? Oh, that came out with 5% more thrust. Awesome. We'll do that in the real world and we'll see if it actually works. And so a lot of people don't realize that there is, even in modern aerospace engineering, there is an iterative process. Well, no kidding. You build it in the real world, you see what it does, and you recalibrate your test, your CAD test profiles and your test simulations, and then you'll work towards a common baseline. Once you have that established, then you see what's better or what's worse. So I love CAD; it's great, but it still has its limitations, real world limitations, especially when you get into the world of complex, multi-array of fans and 18 or whatever it is, 16 blades or 16 rotor quadcopters or octocopters or whatever you want to call them. So it challenges even the modern CAD.
And eventually you're going to get a machine up in the air. You've got to get a machine up in the air, right? And someone's got to fly it.
Yeah, exactly, Ben. Exactly.
I'm just wondering if that will be the CEO of Horizon Aircraft that does that at the time, or your employee test pilot.
Oh no! So first we're going to obviously test it in a pilotless configuration. So it'd be silly with modern technology to throw a pilot in right away. So we'll do some autonomous testing. But let's be honest. I mean, pilots are going to be required to fly these machines around for the foreseeable future, and we're quite practically oriented. So the really great thing is, like I said, in our network, we have some of the leading military test pilots that have gone through in my era and then gone to the private sector. So we've already talked to folks, some of my buddies, about what a test program would look like and how to test that type of aircraft properly, safely. And you never know, I might jump in there for one of the first trips.
Yeah, okay. All right, well, I'm sure that's a good thing. But a while down the road yet, maybe. Is there anything else you'd like to add?
So my thanks again to Brandon for taking the time out to speak to me. Fascinating to hear about the development of the X5, and I'm sure you, like me, wish them luck in their future test and development program. So the next few podcasts will be on slightly different topics, most likely to do with hypersonic and supersonic testing in advance of our real live event that's happening in London in September. So subscribe, and I hope you can join me for those.